Dear students and participants of the course on railway engineering, today we will be continuing with our discussion on the railway failures, and then we will start our discussion on the wears in the rails. In the previous lecture, we did talk about the various types of the rail failures, the coding of the rail failures, the categories as A, B, C, D, E, F, those particular categories were also looked at, and then the specific types of failures were also talked about, say the wheel burns and the scabbing. Today we will be talking about few of the rail failures, and then we will move into the metallurgical investigations. What are the cases where these type of things needs to be done, what actions can be taken in the case of rail failures, and what are the precautions which should be taken when any of the rail failure occurs. Based on the time, we will move into the rail wear, and then we will first of all talk about the reasons due to which the wear in the rail may occur. Continuing with the rail failures which we were discussing in the previous lecture, the another can be the rolling contact fatigue. This rolling contact fatigue, from the name itself, defines that it is occurring because of the contact area of the wheel with the rail sections, and this rolling contact fatigue in short is written as RCF. So, if there are any of the rail section, if this RCF is being written, it means it is a rolling contact fatigue on this rail section. And there can be different type of failures which may occur under this particular category of RCF. So, these can be like the gauge corner cracking or a head checks, shelling or flaking. These are the different categories which becomes a part of this RCF, and they occur mainly due to the development of excessive shear stresses at or close to the wheel and the rail contact area, which exceeds the shear limit of the rail material. I mean, any of such thing which is happening here, because in terms of either the burning, in terms of the scabbing, or in terms of depressions being caused into the rail head, or there may be a possibility of the material which is getting chipped from the rail section or the rail head. Now, all of these things, they are mainly caused due to the inadequacy of the material in terms of either the shear limits or the yield strength, because of the type of load which will be coming at that particular location. Now, let us talk about the first one under this category, which is a gauge corner cracking or the head check. What is this gauge corner cracking or head check? Gauge corner cracking, this is a surface condition of the rail in which the fine surface cracks appear in the shape of fish scales towards gauge side of the rail. So, if we look at this photograph, which is one of the example of this type of the fracture which has a failure which has occurred, you can see this is from the Burhanpur of 2002. It has been kept as an example, so that the new people who join the services, they can look at it and understand the thing. So, here you have to give attention to this section. In this section, you can see that there are the rubbing marks which are being shown in this form, and these rubbing marks, they may be at 10 to 30 degrees with respect to the rail section here, as being talked here, downward angle of about 10 to 30 degrees in the rail surface. And this is not a simple line, this is basically a sort of this type of scaling, and that is why this is being said that this is a shape of the fish scales. So, it will look like in this form, and this gauge corner cracks, they are initiated at the rail surface or very close to it. So, this is the rail surface. So, it is close to the rail surface where it is occurring, and it occurs at an interval of 2 to 5 mm along the rail. So, the gap between these two, this is 2 to 5 mm, and can grow to the same depth at the downward angle. So, this is 2 to 5 mm, and then this is growing for the same value of 2 to 5 mm downwards. So, this is a downward direction at an angle of 10 to 30 degrees to the rail surface, gradually spreading across the rail head. So, gradually all along this particular surface, you will find that this type of a thing is occurring. Once they occur, they usually break out as small wedges or spells. So, you will find that after some time some of the part of the rail section will split. Though gauge corner cracking mainly occurs on the outer rail in curves, but can also occur on the mild curves and tangent tracks where the wheel set or the bogie or the vehicle tends to exhibit lateral dynamic or hunting behavior. So, that means on the gauge side, whatever the rail section is there, on this particular side, because of this continuous lateral hitting of the wheel flange, this type of a thing may happen, and this obviously can occur in the case of say curves, and curves also on the outer curve. So, this is an outer curve and the pressure is being exerted in the outward direction. So, whatever wheel is moving in this form on the two rail sections, there will be a higher hitting here as compared to the inner side. Whereas, in the case of a bogie, if this is being connected with the another one is this form, the pressure will be more on this side. So, here the inner side of the gauge face of the inner rail is going to be affected, and this is dependent on the speed, this is dependent on the weight which is coming at that point, and that is where the dynamic aspect of the weight or dynamic aspect of that static load, which otherwise is getting transferred in terms of the stresses here, that will impact the rail sections. Another one is shelling. Shelling is the internal defect that is initiated at a depth of 2 to 8 mm below the gauge corner. So, if again if we talk about this, and this is the gauge side where the wheel will be moving, then on the gauge corner 2 to 8 mm below, this is going to occur. And generally it occurs in the outer rail in the curved track. So, as we discussed, because there is going to be higher pressure on the outer rail, so it is going to occur there more. Shelling defects do not form regularly along the rail as gauge corner cracking defects. So, they are not basically in the form of a regular condition, they may be occurring at certain locations, and that is all. Shelling cracks develops on a horizontal or longitudinal plane consistent with the shape of rail at gauge corner. So, this is the condition in the case of horizontal as well as in the case of longitudinal plane. So, if we talk about longitudinal plane, so this is the longitudinal plane of the rail section. So, this may occur in this form or it can occur in the horizontal condition. The cracks can continue to grow in the longitudinal direction on that plane for some distance at an angle of 10 to 30 degrees to the rail surface, and either spells out in a shell or turns down and causes transverse defects which eventually results in a fracture. So, at the corner side this occurs, it can move in the longitudinal direction. So, grows in the longitudinal direction, and then it is occurring at an angle of 10 to 30 degree to the rail surface, and because of this particular situation or a condition, it may happen that after some time a portion of that rail head, it may come out of the surface. So, finally a fracture will be caused. The third thing which can be there is a flaking. Now, flaking, from the name itself, it means certain flakes are being created in any of the section. So, it comes out into form of a longitudinal sections which are very thin in form. So, flaking or the running surface checking is another type of the rolling contact fatigue, and this defect occurs on the running surface of the inner or the outer rails. Now, how they can be identified? If you see on this photograph being shown on the right hand side, you will find that there are different points which are visible, which are sort of depressions of a not very big size in terms of a diameter, in terms of a depth. This has happened to the rail head. So, these things they are occurring in the form of a say a mosaic or the snake skin. This type of a pattern will get created at the top surface here, and this is what is a flaking. So, some material from this point has chipped off, some material from this point has chipped off. So, in the later stage spells are produced that can be up to 10 to 15 mm wide and up to 3 mm deep, and it may continuously be moving along the rail section. So, now the size is increasing. Initially it may be very small, but 10 to 15 mm wide and 3 mm deep becomes a reasonable size and may cause issue in terms of the movement of the train at the top of it, where again because of the pockets which will get inserted here of air pockets in these particular depressions, there will be a noise created out of that. This minor flaking associated with minor spelling led to failure if not detected in time. So, if it has been detected in time, then we can do something so as to control it, and particularly in the case of transverse defects initiated from the shelling of inclusions. So, if this thing starts happening, you have a spelling and then you have a say it is being a flaking is also there, spelling is also there, or all of these things have combined together, as we have seen in some of the diagrams previously in the previous lecture where the combinations were shown. In all of those cases, as that time also, as I said, that finally there can be a failure, this particular portion can come out and the rail section will not be usable, it has to be replaced. This may mask ultrasonic signals during routine inspection and prevent the detection of larger and deeper defects in the railhead. This is one issue here because of the combinations, and specifically in the case of transverse defects which are initiated from shelling. There is a possibility even if you are going for USFD detection, it is not being identified, and finally all of a sudden you will find that the rail has fractured. So, here you can see some of those cases that is getting initiated here along the connection of the web and the flange, and then another one is initiated here at this point and then moving it towards the rail end, and finally if these two gets connected, that is a combination which may occur, then this total portion will move out. So, there will be a fracture here. So, as you can see that the fracture has occurred here. These fractures can happen at a localized location along the rail, and it has been shown here. This is not being spread all along, but only some portion has chipped off. Here there is a transverse and the vertical cracking which got initiated in all of the sections, the rail head, the web and the flange, and when they all get connected, now this is a split which will happen in the rail section. So, it gets splitted here. The another case is a piping case. Now, in this piping case there can be two ways in which it may happen. If you see in this section, when you are looking on a rail section, then this is a sort of a piping which may occur. That means some gap has got initiated here and there is a bulking of the web. It is not in the proper shape, it should have been in a shape like this, whereas now it has gone out. Similarly, there is a possibility that it happens in the web in the horizontal form in the longitudinal direction. So, that is another type of a failure which may be there. Now, what are the conditions when we should go for a metallurgical investigations when any of such type of failures occurs? So, let us look at that. The first one says when the rail failure is within first 25% of the service life. Say we said the service life is 50 years and within 10 years some defect has occurred, then in that particular case that is what it says, the irrespective of the type of the fracture or the flaw, what type of it has happened, it has to be sent for the metallurgical investigation to see that what were the problems with this combinations in which this rail steel has been produced and the rails have been manufactured, and if it is being observed that there is some issue, then all such sections has to be replaced. The rails have been removed from the track as a result of the visual or the ultrasonic detection, and the rail failure falls in the categories as being prescribed. Under those cases also the metallurgical investigation has to be initiated. The rails where the rail and the weld failure is prima facie a case of the train accident, and then it should be sent to the RDSO, the Research and Development Standards Organization of Indian Railways. So, it has to be sent there and they will further go for the investigation. The rails with the repetitive failure of same rolling mark irrespective of the type of failure. So, in that case also it has to be sent to the metallurgical investigation. Then in the case of the failures of imported rails occurring within the guaranteed period, irrespective of the type of the failure or type of the flaw which may happens, now a piece has to be taken out, and this piece is approximately 1 meter long, 500 mm and 500 mm based on wherever the flaw has occurred. So, 500 on either side of it, total 1 meter is to be taken, containing the fracture and flaw detected visually or by ultrasonic flaw detection, and then it is sent to the metallurgical investigation as well as to the chemist check out that what was the problem with this type of a rail section. Now, there are certain codings which have been given, and these codings are related with the type of the failure which may occur. So, it says that if it is the transverse breakage with apparent origin, that is sudden breakage is there which is being coded as 100200, then in that case it has to go for metallurgical investigation. If there is a head surface or shallow surface defect all along the line of track which is being coded as 1212 or 2212, then in this case also it has to go. The third one is the web horizontal crack at the top fillet radii. So, the top fillet radii here, there is a horizontal crack which is propagating. So, being defined as 1321 or 2321. Web horizontal crack at the bottom fillet radii. So, at the bottom fillet radii means here. So, if it is getting in this form, so a crack is occurring here, in that case it is 1322, 2322. Web horizontal crack not in the fillet radii. So, horizontal crack can be here. So, this is 1323 and 2323. Then web diagonal cracks not at a hole. So, there can be holes here, but it is not happening on the hole. Say the diagonal crack is occurring here like this, which is being coded as 238. So, in those cases also it has to go. Then the foot vertical longitudinal crack in the foot half moon break. So, it is a half moon break means the break has occurred in this form in the foot area. So, that is being coded as 253. The foot transverse break at a rail seat. So, at the rail seat itself, if there is a breaking in the transverse direction which is coded as 1511 or 2511, then also it has to be sent. Then foot transverse break which is not at a rail seat which is coded as 1512 and 2512, that means the last code has changed here. Then internal flaw in head or the transverse breakage if it is there which is coded by 3 digits as 111 and 211, or internal flaw in the head or the horizontal crack defined as 112, 212, or internal flaw in head or vertical longitudinal split which is defined as 113 and 213. In all of these cases this is to be done. Along with that, there is in the case of a web there is a vertical longitudinal splitting which is 133 and 233 being coded, or there is a web lap which is occurring as 139 and 239 code, or there is in the foot there is a vertical longitudinal split which is coded as 153 and 253, then all of such cases the metallurgical investigations are initiated. Now, what actions to be taken here? Now, whenever a fracture of a rail or a welded joint is noticed, immediate action is taken to restore the track, if necessary with restricted speeds with the least possible delay. So, there are two things which may happen: immediate action may be required, restriction of the speeds may be imposed, and delay should not be there. In the previous lecture I talked about it, that there can be a possibility that immediate action which is to be taken is immediately within say 3 days, or can be within 15 days, or it can go more than 15 days, but goes into the continuous observation. And if it is found that something is happening, then the appropriate action is to be taken. If the fracture is with a gap of less than 30 mm, the fractured rail ends should be jointed with the fish plates and the clamps. So, we can push in the fish plates there along with the clamps, and that can be remain there. But say if it is more than 30 mm, then a rail closer is inserted there of whatever is the size of that particular gap. So, that rail closer will be there, it is inserted, and then the fish plates and the clamps are placed at the top of it, so as to keep it in position. So, you have reduced the gap by insertion of a rail closer, and then as well as have put it in place by way of the placement of the fish plates. Now, in case where a small portion or a piece of the rail has come off, or in case of the multiple fractures, the rail has to be changed before allowing any traffic. So, if all of these things are happening, then we need to take a action on this. In the case of the valve failure, the joggled fish plates and the clamps should be used. So, we have gone for SWR, we have gone for LWR, and the weld has failed, and weld could have failed because of some reasons in the case of technique or in the type of metal which has been used for the welding at that location. So, there the joggled fish plates are used. These are the special type of fish plates, not the standard or the conventional fish plates. So, we will be discussing about this when we will go into the fastenings. Now, what are the preventive measures? The preventive measures are slack sleepers, which can be that during the packing of the ballast the sleepers should not tilt. So, when you are putting the sleepers and putting the ballast and packing the ballast, that a precaution has to be taken. Loosening of the fish plates, that can be a problem. So, tightening of the fish bolts is to be done, but in such a manner that the contraction or the expansion which is required with respect to the change in the rail temperature with respect to the implementation temperature, then that should not be a problem, it should happen. Then the wear of the fish plates and the rails at the fishing surface, if they are, then provide the tempered shims or replace the rail end. Okay, so at any of the fishing surfaces if it is happening, or the fish plates which have been provided at the top surface it is getting weared out, then this can be done. If there is a battering of the rail hand, then the end cropping is to be done, and the firm packing at the joint sleepers, correct the expansion gap. These are the things which needs to be done. So, once you have cropped it, you will put another rail section there, and then the packings will be done at the joint, because this joint sleeper will be the first sleeper from the joint itself, and the expansion jabs has to be correctly provided. In case there is a hogging of the rail joint, then the cropping of rail ends, this is to be done using the repressed fish plates. So, first of all we will remove that particular section, and then some other rail section has to be placed, and on top of that then the fish plates are going to be further repressed. Broken fish plate, if the fish plate itself has broken, then there is no other remedy than the replacement of a fish plate. If they are cracked or the broken rail ends, then in that case chamfering of the bolt holes or the bone holes can be done up. So, this is another way of preventing the rail failure. So, if it is being done, so you have to improve upon the section and then go ahead. Pumping of the joints, that means through the joint some material is coming out. So, what we have to do is first of all remove, and then replace the ballast at such joint. Means there is some issue in the case of the ballast, and because of that it is coming out of it. The cross drains between the first and the second shoulder sleepers, that also needs to be taken care of as a preventive measure, so as to stop the pumping at the joints. Now, let us move into the rail wear. So, we talked about the fractures, we talked about the various types of the defects. Now, what is rail wear? Let us talk about it. Now, this is one of the type of the defects of course in the rails, and this rail wear, this can happen on the surface of the rail, either on the top or on the side of the rail head, or it can occur at the end of the rail head. So, that means in any of the rail section, this may occur at the top, this may occur at the side of the rail head, or if we are talking about this continuous rail, then it may be occurring at the end of the rail head. So, these are the three positions where this wear can occur, and this occurs due to the friction between the moving loads and the wheels. If the removal of the material from the surface is more as compared to the permissible limits which have been given. So, if we are talking about this sectional area, say whatever is the width of the rail section which can be there. So, this width of the rail section is always being provided with plus minus x mm, which is the permissible limit. So, if everything is within the permissible limits, then there is no issue, but if it is going beyond the permissible limits, then that is being designated as wear. Now, let us come to the various reasons of wear. The very first one, abnormally heavy loads. Now, when we are talking about all of these cases, the reasons which may be there, we need to consider the same thing which I have drawn in the previous slide, that is this section, wherein the wear can occur in the top surface, the wear can occur on the side of the rail head. So, this is the rail head, and or it can occur at the end of the rail head. So, if we are considering it in this form. So, abnormally heavy loads, means abnormally heavy loads obviously are going to be on the top of the rail head. But we have also discussed that when the two rails, they have been jointed together in this form, and if there is a problem with the gap, or if there is a problem with respect to the level of the two rails, the rail 1 and the rail 2, and there is a movement of the wheel at this location, then there is a hitting at the rail end. So, there is also a possibility that abnormally heavy loads subjective to a condition that either there is a level difference between the two rails or there is a bigger gap as compared to the standard gap, then it can also occur at the rail end. High speeds of the trains. Now, when it is at high speed, the dynamic effect is going to be there. We have discussed about this dynamic effect when we talked about the rail stresses or the stresses which are induced in the tracks. So, if we are looking at this high speed, so there is a factor, a speed factor with which the speed is going to be multiplied. So, there is an augmentation of that effect, and because of this augmented condition, the impact which will be there at any of the location, maybe at this point or maybe the impact here at the top of the rail head, or maybe the impact on the side of the rail head because of the movement of the wheel and the flanges, this may be higher, and therefore, there is a possibility that in any of the such situation the wear may start occurring. Impact of the moving loads. So, this we have combined with the discussion with the high speeds. The moving loads we can also talk in terms of the lateral movement, and this lateral movement will be causing at the rail head side. Then concentrated stresses which are exceeding the elastic limit of the rails. We did talk about this in the case of the rail fractures also, the rail defects also. At any of the location, if because of the heavy loads which are coming and the rail section which is being used in terms of its ultimate tensile strength is not adequate enough to take up those particular loads in terms of the longitudinal vertical compressions or in terms of the lateral stresses which are induced, then there is again a possibility of these type of rail wears to occur. Gaps at the joints, as I was discussing about this. So, if the gap is more, and along with that not only the speed, but the diameter of a wheel. If the diameter of the wheel is smaller, then this contact at the location where the gap is more, it will be higher, and because of that there will be more transfer of the energy in the rail which is being provided in the forward direction. So, this is also an issue, and obviously in this particular case this is going to make an impact at the rail end. The slipping, skidding or striking of the wheel flanges on the curves. Now, when it is happening, then because we are talking about a curve here, we are saying that this is a curved section, the wheel is being defined here. So, this is how it is moving in a direction. So, when this happens, we have already discussed, because of the centrifugal force which is acting outwards, there will be the lateral movement of the wheel flanges, and this lateral movement of the wheel flanges, this will be striking. And in some of the cases, because of either the application of the brakes or maybe on gradient or likewise, if slipping or skidding also takes place, then that will also be a problem, and it will create the wear specifically either on the side of the rail head or maybe at the top. Acceleration, deacceleration and braking of the wheels. Now, these things are correlated here. Now, first of all, when we talk there, now acceleration and deacceleration can also be talked in the case of a normal section, say at a platform. So, if the train is at a platform, it is going to stop. So, there is a deacceleration going on, and it has stopped there. Now, it is going to move back. So, there is a departure time. So, it is going to accelerate. In all of these cases, the effect will come to the rail head, the top surface. Similarly, when the braking of wheels are being applied at certain locations due to any of the reasons, then this is also going to impact at the top surface only. Abrasion due to the rail wheel interaction. Now, rail and wheel interaction and this abrasion, this will again be coming at the top surface, or it will be coming at the side here, because there is a continuous rubbing action. So, when this rubbing action is happening like this and this rail is being tilted. So, when it is being tilted, so it will go in this form at 1 in 20. So, there is a rubbing action on this particular surface. Effect of weather conditions, say temperature variations, snow and rain. So, these impacts, if it is wet surface on the rail, the impact will be different as compared to the dry surface. If it is a high altitude area and the snow is there, then again there is going to be a problem. And similarly, when the temperature changes are there and there is a movement of the rail in terms of an expansion and contraction, then also there will be a problem. Say if it is a contraction and the gap widens, then there will be an issue with respect to the striking of the wheel at the rail end. Presence of external material. We have discussed about the sand in terms of the coastal areas, in terms of the desert areas, and as soon as these sand gets accumulated at the top like this, and there is a continuous interaction between the wheel and the rail surface, so this abrasion will start occurring here. So, there will be more wear at the top of the surface of the rail head. And the maintenance of the track, of course, maintenance is one thing which in all of cases you will find that this needs to be taken care of. If it is not being taken care of, there is a loosening of the fastenings, there is a difference in the levels of the rails, or there is a problem in terms of the formation of the ballast cover which is being provided at the bottom. So, in all of those cases, then the impact will come to that particular section in terms of the higher stress is being induced, and that will finally cause some wear of any of the portion of the rail section. So, we stop here. We will be continuing with the rest of the things related to the rail wear, because this is not being completed. So, we will take all of those aspects related to the rail wear in the next of the lecture. Till then, bye and thanks.